for having us. I've been really looking forward to this exchange. I'm going to share my screen, and just to let you know, it'll probably go dark once I launch the slides. Not quite sure why that is. It's something to do with my laptop or something, but let's see if I can just launch it, and it'll go dark for about 5 or 10 seconds. Hopefully you can still hear me, or?
Yes, we're still hearing you. And
okay, all right. Should show up hopefully in the next few seconds. I'm not quite sure why I got this crazy delay, but there we are. Hopefully you're seeing the slides now.
Yes, it's up.
Perfect. Thanks again, Sherry, for that very warm introduction. Real pleasure to be again having the opportunity to connect with all of you in Jamaica. Per your very kind invitation, I will give an introduction to We Robotics and the Flying Labs Network, and then share some concrete examples of how emerging technologies such as drones, robotics, and AI are being used by the Flying Labs in humanitarian contexts as well as in public health contexts. So to start off with, We Robotics is a local first not-for-profit organization. And by that we mean that we are very much dedicated to the power of local, which means the focus on local leadership, local ownership, local expertise and knowledge, and local lived experience. We believe that without that, any kind of technology for good projects is at best going to have little to no impact and certainly not be sustainable. At worst, will actually create harm. And there is unfortunately plenty of evidence over the past decades where foreign-led, top-down, and technocentric approaches to social good have indeed resulted in serious harm. So the way that we go about this power of local and in fact shifting power back to local experts is through the Flying Labs Network, which is co-created with a growing number of experts across 30 plus countries around the world. Flying Labs, like Jamaica Flying Labs, are hosted by existing organizations that have a demonstrated track record in the application of drone technology in the social goods sector. And the Flying Labs are all connected to each other as local knowledge hubs run by local experts. They exchange insights, lessons learned, best practices, new opportunities, and more. And each Flying Labs is also directly connected, I think, obviously within their own ecosystem or ecosystems in their countries. So connected to key actors in government, industry, universities, civil society, and so on. And together they do indeed very much represent and demonstrate the power of local leadership in tackling local problems. Now, of course, these are just more than dots on a map. We're talking about a wide range of expertise that span the entire thriving Flying Labs network, from engineers to entrepreneurs, scientists, educators, change makers, and so on. This truly thriving network of vast and growing expertise is why there will always be more expertise within the network than in the small non-for-profit called We Robotics. And so our role then within the network is to serve as an enabler in helping to facilitate knowledge exchange between all corners of the Flying Labs network, helping to facilitate knowledge exchange from industry and other parts outside the network back into the network as well as needed and if needed. We also are involved in helping to accelerate technology transfer from industry to Flying Labs based on the priorities of Flying Labs. And I should mention that Flying Labs are very much independent knowledge hub. Flying Labs decide what projects to prioritize and what partners to team up with. And in addition to this knowledge exchange and technology transfer, we're also involved in what we call opportunity transfer, to basically mean that, more often than not, we see that these projects, like I said earlier, are kind of foreign-led. So when we get wind of new projects whether it's from companies or multilateral organizations or large NGOs. We try and guide them to the flying labs instead of having them hire foreign consultants and organizations from the US, Europe, or Australia. And so that's what we mean about really, altogether shifting power back to local experts. And so the way we serve as an enabler across the network as well is through key programmatic areas that flying labs are particularly active in. One of them is in development, so the application of drone and so drone technology, AI, in sustainable development, property rights, and so on. In the humanitarian context, in terms of disaster risk management, resilience building, so on, and in the environmental space as well, which includes not only agriculture, but nature conservation and climate change adaptation. And fourth, in the public health space, and we'll be talking about that a bit more, so I'll get into more details in a few minutes. And last, but certainly not least, more and more flying labs are actively engaged in the youth space and in the STEM education space, really working directly with youth in their own countries, introducing them to these new technologies and the kind of opportunities that these new technologies can offer. So that's also a very exciting program for the Flying Labs Network and We Robotics. So I'll now give you some quick examples from the Flying Labs Network on how these technologies are being used in humanitarian and public health contexts. To give you a quick example as to why we would even want to use drone technology in disaster response, I'll give you an example from now 6 years ago in South Pacific, when Cyclone Pam, Category 5 cyclone, devastated the islands of Vanuatu. Now, if you're on the ground and mobilizing in response to this disaster and being asked to quickly, rapidly assess the extent of the damage, the type of damage, the resulting needs from affected communities, you're not going to see much by keeping both feet on the ground, right? If you're looking out here at the extent of the damage and the number of displaced peoples, you're limited by your perspective necessarily. But a drone like this one, when it's overhead, can take very quickly thousands of very high resolution photos like this one. Photos that really allow you to get an at a glance immediate understanding as to the location of the damage, the extent of the damage, the type of the damage, and allows you to also identify where possibly some local communities have been displaced. And being able to do this relatively quickly means that the faster you can assess the damage and the needs, the faster you can start assisting in a way that's informed by evidence rather than guesswork, which is often the case in humanitarian efforts because that data is lacking. So it's certainly not a criticism. You just have to do the best with the information or the lack thereof that is available to you. Now, where does all the information, where does all the time go in humanitarian drone missions? Now, we've made some progress here, but still, at most 5, maybe it's gotten to 10% of the time in humanitarian drone missions go to actually flying. That's when the drone is actually up in the air. But the fact is, the vast majority of the time is still very much focused on swearing or sweating or both. And that is because it still can take a significant amount of time and it can be extremely time-consuming, tedious to do everything else that needs to be done before and after the drone gets in the air. This is, flight permissions, mobilizing your pilots, making sure the technology, the drones are ready to go, actually getting to the affected location. That can be particularly challenging. So just logistics in the wake of a major disaster. Having your own media communication strategy in place. How are you going to communicate with the media? Connecting with humanitarian organizations who are ultimately those who are looking for the kind of imagery and data and insights that your team can actually provide through the use of drone technology. And when the drone lands, that's unfortunately not the end of the humanitarian drone mission, because then it's about quickly processing that data, being able to then analyze that data and turn that data into action, into actionable insights. And so that's a lot of what we do, and what the Flying Labs do is help build that expertise and expand that expertise within their own countries and regions through dedicated trainings, best practices, lessons learned, standard operating procedures, checklists, and so on. Now, to give you some very quick examples of Flying Labs in action across the globe, this was a project a while back that Peru Flying Labs led after some major flooding in the northern part of the country. They were the first team on site with drones, working directly with the municipal governments in doing damage assessments, but also search and rescue, identifying people who were trapped and getting them rescue efforts pointing their way. Tanzania Flying Labs also now about a couple of years ago were asked to respond by the Emergency Management Office of the capital, Dar es Salaam, to some of the biggest floods in 100 years to assess the extent of the flooding and the damage. And like other Flying Labs, Tanzania Flying Labs is making increasing use of AI or machine learning to help do automated feature detection. And this is really key because aerial data really is a big data problem. And so we absolutely need to move from manual analysis whenever we can to more automated, accelerated analysis in order to then be able to assess far more quickly. So Flying Labs are certainly not just involved in data collection, which is certainly a particularly challenging thing to do in the context of humanitarian disasters. They're also very much involved in helping to turn that data into actionable insights in order to then inform decision-making in a data-driven and timely manner. India Flying Labs also has been actively involved in flooding, and you'll find that a lot of these examples are flooding because flooding really that leads to the most damage and loss of lives compared to any other disaster per the statistics over many decades now. So continuing on the flooding side, Côte d'Ivoire Flying Labs in West Africa responding to a request from the World Bank also to do a flooding damage assessment. Senegal Flying Labs responding to a request from the Red Cross to do also flood assessments. And you see here, the green is actually algae floating on top of the water. So it's quite extensive flooding here as well. Pacific Flying Labs has been involved in response to cyclones in Fiji, for example, again, at the request of the Red Cross Society there. And then Nepal Flying Labs has been involved in disaster response to the earthquake back in 2015. They were actually one of the first Flying Labs to join the network. They've also been involved in responses to landslides. And I really like what they've done in terms of then unlocking that data, because obviously not everybody will have access to a tablet or a laptop. And so what they've done, and that others have started to do as well, is to then print out these high resolution maps and engage in community mapping with local communities, because obviously it's the community that has the expertise and the local knowledge. They're the ones who know their communities inside out. So enabling the community to make their knowledge, their expertise tangible through this kind of public participatory GIS can be a really powerful way to enable the community to share its expertise and to have its expertise validated as well. So that is a quick overview on the humanitarian side, closing with the code of conduct that we have been spearheading now for well over a decade. If you are interested in humanitarian applications of drones, I very much invite you to check out uavcode.org. It really is the only code of conduct of its kind, with strong input and contributions from a number of international global humanitarian organizations. On the health side, and just to close up with this, this is actually a satellite image of an area where Nepal Flying Labs has been active for the better part of about half a year in doing drone deliveries. And you see the orange line here, that's actually the road from the regional hospital to one of 8 remote health facilities in the foothills of the Himalaya. And it takes on a good day about 4 hours to get from Bhutan Hospital to Mashkot. And that's because the roads are somewhat challenging on a good day when it's sunny. They're even more challenging. And I'll show you some footage shortly. But basically, compared to a 4-hour drive to Mashkot Hospital, a drone flight can in under 10 minutes. And again, to drive the point home, this is the footage that Nepal Flying Labs kindly shared. I mean, these are gorgeous mountains, just beautiful. And you see the roads are carved into the hillsides or to the mountainsides here. And this is actual footage from one of the cars heading to the facility to pick up some TB samples. And again, notice there's no rain, right? So this is actually a good day. And that really explains why it does, take some 4 hours to get there, and why a drone that goes line of sight really is able to get there in under 10 minutes. So Nepal Flying Labs has been leading this project with a number of key partners. They're actually, I just got a note from Nepal Flying Labs this morning. They're going to be resuming this now. There were some interruptions due to the pandemic and restrictions on movements, but that seems to now is being put back in place. I'll show you some more footage just to make it more real and less abstract of the platform that the We Robotics team repurposed that you see right here. It's a DJI M600 for those of you who are involved in drones. So we repurposed this very reliable industrial drone into a cargo drone. That allows us to really keep the costs low and affordable so that these platforms can be locally maintained and locally operated. And the Nepal Flying Labs team now really owns these platforms, working with a number of local partners and the municipality in order to collect TB samples from 8 remote clinics, bringing them back to 2 regional hospitals like this one here. And this has had an incredible impact because now, instead of having to wait days, if not weeks, for patients to get a diagnosis of their condition to determine whether it's TB or not, they can actually get this done within hours, within like a day at most. And what's fascinating is what that has done is that it's actually encouraged more and more local members of the community to get tested when they're starting to feel certain symptoms and not to wait. And the reason they've been waiting in the past is because, well, they don't know, they won't know for weeks whether it's actually an issue. And because that feedback loop now is so much more rapid, it actually is now actually increasing, traction from the local communities, because they're now seeing a health system that actually works more favorably to what their health needs are. Flying Labs have also collaborated together from across the world on joint cargo drone projects. This is one project in Papua New Guinea. As Cherie kindly mentioned, Peru Flying Labs has been involved in projects with BD a while back now, and again looking at existing drone technology and repurposing mapping drones into cargo drones. And Dominican Republic Flying Labs has also been partnering with Pfizer to deliver essential medicines as part of a proof of concept a year or so ago now. And you can see, just to drive the point home, right, the blue line here is the road that you have to take from San Juan to Bohechio. And that will take you a good while. Again, not the entire road is not all paved, but if you go line of sight with a drone, it's barely 10 kilometers, and you get that done in 5 minutes, basically. I mean, give or take. So it is quite a change for that kind of operation. And all Flying Labs who are engaged in these cargo drone projects are not there to just run cargo drone projects indefinitely. They train other local drone companies, municipalities, local NGOs, as well as nurses and doctors to better understand themselves how to operate these technologies. And so I invite you to check out the We Robotics and Flying Labs blogs to learn more about any of these projects that I've shared. It's all documented, fully transparent way, lessons learned, what went right and what went not right. That usually is much more important than what went right for learning purposes. We also have an online training academy that's available to all, but freely available to Flying Labs and at a nominal fee to others outside the Flying Labs network. And that is it. Please do visit flyinglabs.org. This is where all the action is. This is where the learning is, the innovation is. And I can't tell you how just a privilege it is to be able to be connected with Flying Labs all around the world and learn from them, share what we're learning as well, and just to see the impact and their leadership in the technology for good space. So thank you very much for having me. Again, I really appreciate it.
Okay, thank you. Thank you, Patrick, for that presentation. Thank you for providing insights on the many applications in humanitarian and health aid so that as experts in our respective fields, we can appreciate how AI technology and aerial data can be used to provide support for our local communities. So thank you again, and without further ado, moving on to our next speaker. So our next speaker is also from We Robotics. Joseph Malhausen has over 10 years of experience in GIS, image analysis, large-scale data projects, and drone system design. Joseph joins We Robotics from the World Bank, where he has spearheaded some of the most interesting and challenging drone projects in multiple regions, including Latin America, Caribbean, and the South Pacific. Indeed, he has led efforts to improve agricultural practices using drone imaging, including a project to assess rice irrigation with thermal sensors in the Dominican Republic. As the founder of CL Map, a drone mapping company, Joseph has worked with local partners to create the first flood model of the Marshall Islands, thereby demonstrating the benefits of using cost-effective drone solutions for economic challenges. Joseph holds a dual degree from Sciences Po Paris and Columbia University in Public Affairs, and has obtained a master's degree in GIS and remote sensing from the UPMC Sorbonne Universities. So I'll hand over to you, Joseph.
Thank you very much, Sherry, and thank you for the great introduction. So I'm going to follow up on Patrick's amazing presentation and talk about environmental monitoring. I will not cover kind of all the general bits about Flying Labs and We Robotics, but we'll jump right into kind of a more technical aspect of our work. I don't know if you can ask questions, but at the end of the presentation, we will go through a couple of case studies. And if you have any pressing questions, or if I've missed anything, please feel free to ask in the chat or directly. So I'm going to talk about environmental monitoring with drones, which can be quite a broad subject. In this presentation, I'm including things such as sea level rise, for instance, which has an impact on the environment, all the way to maybe chemical spills. I don't have any examples about chemical spills, but keep that in mind. Also, when I talk about drones, I talk about small drone systems, such as what you see usually off-the-shelf DJIs, sense flies, and so on. I'm not talking about very large systems that are equipped with different types of sensors. So just to start with the definition. And I'm going to jump right into, bear with me, this is the only technical slide, into a little bit of a background. If you have a background in GIS, this must be easy for you, but just in case some people are not familiar with this, drones can have different types of sensors that I will present after that. I just wanted to kind of let you know what these sensors measure. So we see in the visible spectrum that you see basically the colors. And the sensors associated with this is called an RGB sensor, just for the sake of defining those. We also have drone systems, sensors that we call multi-spectral, often used in agriculture, and they work in both the visible spectrum and the infrared spectrum. Light that we cannot see, but is useful for anything like chlorophyll concentration. And finally, a little bit farther, in the wavelength, like larger wavelength, we have what we call thermal infrared. You've probably seen videos of, at night, someone walking and emitting energy that can be measured with a thermal infrared sensor. So just a quick introduction, and now let's jump into the types of sensors that can be used, and how they are applied to environmental monitoring. So the first ones are, as I mentioned, RGB sensors. They are off-the-shelf cameras. You have different declinations of these sensors. Some of them you can just buy them at the store. Some of them you need to work with a drone company, or they are already included in the case of the DJI, for instance. These sensors collect photos that are then stitched together to create orthomosaic or a map. You have one down below, which is was collected in Tanzania to look at land use and land cover in a rural region of Tanzania. You get from these sensors information about, as I mentioned, the visible spectrum. So it's anything that you can see with your eyes. And with regards to any environmental monitoring, it would be changes that are visible to you. So chemical spills that are visible in the background, any sort of major damage to the environment, such as change of color in plants or vegetation, any sort of foreign objects, landfills, and we'll see a case study on that. Anything like that can be seen with an RGB sensor. These sensors are very common, very affordable, and it's usually what you will get when you work with drones for environmental monitoring. Next, we have what we call multi-spectral sensors. So these can see a little bit or collect a little bit more information than RGB sensors, and give you, let's say, information that you cannot sometimes see, or that will be seen in the future, meaning that maybe the environmental impact is happening, the algae is blooming in the lake slowly, but it's not yet visible in the visible spectrum. So these multispectral sensors, or sometimes we call them hyperspectral, would be more useful. Not going to get into too much of the technical details, but know that they are less common, much more expensive, and are only compatible with specific drone systems. So you need to basically do your homework before attempting to use one, to make sure that it's compatible with your system. Just a side note, the resolution is not as high as RGB sensors. So if you want a very high resolution, you should prioritize RGB sensors. Next is thermal imaging, which is, you might be familiar, as I mentioned, with anything like videos from anti-poaching operations in sub-Saharan Africa, or things like that. But they can also be used to identify any sort of chemical leak, on a pipeline, anything that has a difference in temperature with its surroundings. So that can be useful for environmental monitoring. It's used a lot in urban settings for different applications, from energy to solar panel installations and so on. And it's also used in some agriculture settings, which is a little bit outside of our scope, but to monitor the efficacy of the irrigation in an area. And this one, so this is quite a different sensor. Again, some people might be familiar with the sensor. It exists on airborne systems, manned aircraft, also some satellites. It has its own light source, so that's why I didn't locate it in the light spectrum. It basically emits laser light many times per second, up to 1,000 times, and receives the return. And using the time that it takes for this return to come back, it's able to reconstruct terrain in 3 dimensions. So that's what you see at the bottom right corner of the presentation. So this is a point cloud model from a LiDAR sensor. LiDAR sensors are very accurate. They will allow you to then use the data for any sort of engineering or any sort of accurate measurements. For environmental monitoring, if we talk about, for instance, deforestation, you could get additional information than RGB sensors, because you can sometimes, for some LiDAR sensors, see through the canopy or see through the vegetation. So there is additional advantages to using LiDAR. You can also see through sometimes. When I say see through, is across crops or leaves or any sort of vegetation. It's, however, quite expensive, not very common with drones, and it uses a lot of energy. So if your drone system flies for about 30 minutes, if you install a LiDAR, you may get down to 5-10 minutes tops. So if you expect to cover the same area with a LiDAR, it's probably not the case. Okay, so we've covered the sensors. Now let's look at a couple of use cases that were done by Flying Labs themselves in environmental monitoring. So I try to focus on kind of small island environmental monitoring cases. There are other types of applications within the Flying Labs network, such as glacier change detection. We have obviously, Patrick talked about floods. You know, if there's any sort of chemical or microbial issues with the associated with the flood and so on. Let's look at the first case here, which is in Panama. It's an island called Cayo Zapatia, off the coast of Panama, I believe, on the Atlantic side. And as you can see, I mean, you can see the people on the beach, and they are, I mean, it's a very low elevation island. This island is threatened by climate change and sea level rise. It's not a populated island, but it has a thriving ecosystem, and the community, as well as the Panamanian government, would like to find mitigation solutions to preserve that ecosystem in the future. So they've hired Panama Flying Labs to create a map first with an RGB sensor of the whole island, and also collect terrain and elevation data. So with drone data from an RGB sensor, you can derive elevation data. I'm not going to go into too much detail on this, but they've mapped the area and then created a model based on the elevation data that estimates the extent of the flood based on different scenarios. So what you see on the right-hand side is an animated GIF that shows different, let's say, storm surge level associated with different sea level rise prediction scenario. It's a basic model. There's nothing dynamic associated with it, and this is why you see patches of water inland. It could happen. Sometimes the water goes to underground and then pops out within the island. So that was done with, let's say, off-the-shelf drone systems, 6 flights. I believe the processing was a few hours, and then the analysis on ArcGIS took about a day. And this is the type of data set that you can obtain. The community and the government are looking at this now to see if planting mangrove around the island could be a good mitigation strategy, and this will help them find the best location for the plantation of mangrove. So that's the first use case. Let's move to a completely different use case, still in Panama, Cerro Patacon, which is a big landfill near Panama City. The Panama Flying Labs has worked with the city authority to monitor the landfill using drones. This is a first in the area. Some of you may be familiar with landfill challenges, which range from, overfilling to any sort of gas emissions or even fire sometimes. So Panama Flying Labs, I'm just gonna show you a couple of on the ground pictures that are not from us, but just to get a sense of, this is a big area. And it's a major challenge to manage properly. So Panama Flying Labs collected the same type of data as before, RGB images of the whole area, which represents about 250 hectares, which is pretty large, to evaluate where there might be overfilling, and monitor over time the change in landfill volume. There are also other objectives, which include preventing any sort of risk of fire to the local community nearby. So this was flown a little higher. It took about a day to process, and same for the analytics. All right, and then our last case study, which is in the Seychelles, which was done by my colleague Sonia, was aimed at counting fauna or monitoring fauna around the, not sure if we call this an atoll, but around the surrounding of the atoll. And actually the subtitle is wrong. This was done in collaboration with the SenseFly company, and they flew same types of sensor with SenseFly drones in this case. And finally, so this is my own work. It's kind of a similar flavor as the first project, done with a slightly different drone system. So this is the Marshall Island, which is in the middle of the Pacific Ocean. This is one of the atolls in the Marshall Islands. And this is to give you, so it goes a little beyond the environmental monitoring, but it's to give you a sense of how you can then, as Patrick mentioned, make actionable insights from the data. So the area was mapped. This is about 7 square kilometers. It was mapped in a few hours at high altitude. And then the terrain was calculated, and scenario, sea level rise scenario were applied to this island. And so you can see the different type of events that could happen. There's an airstrip on the left-hand side. This island is really far. It's a few days away from the other islands by boat. So the plane is really the main transport on the island. So you can see that as the sea level rises, the community is going to have to either make changes to the runway or relocate, because also the populated area is also threatened by this type of events. So that's outside of the scope of this presentation, but it's to give you a sense of how you can make actionable data. So this is the end of my presentation. Let me know if you have any questions. Thank you very much.
Thank you, Joseph, for that presentation. I'm going to check if there are any questions in the chat. Are attendees able to raise their hands if they have a question? Not hearing you, Josiah, you're muted.
Thank you. They just need to type it in the chat, sure.
Yeah. So we encourage you guys to, if any have any questions, feel free to put it in the chat. We are here, we can answer.
Okay. All right, so there are no questions at this time. I'm going to move on to our third speaker. The third speaker is Josiah Burkett, who is an analyst here at GeoTechVision. Mr. Burkett has a Bachelor of Science in Geology from the University of the West Indies, Mona. He was introduced to the GIS world at University of the West Indies, and it encouraged him to further his skill sets in GIS with an online specialization from the University of California. He worked as an intern at the Environmental Management Authority of Trinidad and Tobago, where he was exposed to GIS applications, assisting with the mapping of resources within the organization. He then moved on to be a junior geologist with Geophysics Jamaica Limited, where he got extensive experience in mineral exploration and data collection. Recently, he furthered his education with a certificate in project management. Josiah is, as I mentioned before, he's an analyst with GeoTechVision, where he contributes his expertise with the team and aims to provide value through innovative solutions. So I'll hand over to Josiah.
Okay, thank you, Cherie. I'm quickly just going to, give attendees an idea as to how you can use UAV solutions to optimize your workflow. More importantly, not too technical, just speak on some of the offerings that GeoTechVision has, because you've seen all these interesting, presentations from Joseph and Patrick, and I'm sure persons are wondering, how can we, or how can my organization get involved? Where can we get drones? A major question I'm surprised persons haven't asked is training for drones. In my experience, a lot of persons are scared to use drones because they feel they need to be super skilled, or this needs to be their main profession. But it's as simple as, I would always say riding a bike, you just need practice. And with practice comes confidence. And there are, because we are in such a digital age, there are so many solutions that automate these things for you. It's easier than you think. So just to get in, I just wanted to give persons an idea as to how, a general UAV workflow looks, an example. I always like to refer to some of these things because it's important in knowing what you need to do to, get from buying a drone, flying a drone, data collection, and then getting your output. So firstly, you have flight planning. A lot of persons don't know this, but you don't always manually fly a drone. It's really great, and it's probably necessary to not manually fly a drone, because like anything that's technology driven, there can have mishaps, but a lot of flying is automated, especially when you want to get really accurate data. So you would be creating flight plans depending on the drone you're using, the software that is involved. Some flight plans actually can be done on the fly. You go into the field, you look at where you want to map your boundaries, etc., and you do up your flight plan, and the drone actually is automated to fly along those lines and collect data. it's important to do the flight planning first because sometimes you need permissions, and part of your permission would include sending your flight plan. So we always encourage persons in the Caribbean region. A lot of islands aren't as strict because there aren't a lot of airports and there aren't a lot of areas that are high risk when it comes to flying drones. But I always encourage persons to find out because there are a lot of private institutions, let's just say jets, etc., that may be in your airspace, and you don't want to have a drone without liaising with your local authority. In Jamaica, we have the JCAA, so we always encourage persons to do your flight plan, submit or find out if you need permissions to fly. Some persons own their assets in terms of the land. It's an environmental protected area, maybe nothing is going to be in their airspace, but it's always good to know. Then you have your pre-flight safety check. This is something we always encourage persons to do. You can buy a drone and just, start flying, but then you may have instances where there are damage to your drone, or maybe a propeller is going loose. You do not want to send that drone into the air. So I would always encourage persons to do a pre-flight safety check. Then you have your flight execution, which, if it's automated, would fly along the flight plans, the flight plan, collect the data necessary. Maybe you will afterwards do a manual flight and collect videos and images for yourself. That's, just to make sure you didn't miss anything, or probably get it at a better resolution just to use in a presentation to a stakeholder, to a supervisor. You have your post-flight safety check, which is just as important as pre-flight, because you don't want to fly a drone, something happens to it, you put it back in the office, another team member comes along, maybe didn't do a pre-flight safety check, and then they're in problems when using the drones. And we know sometimes these drones cost a lot. That brings back to my point of being scared to fly. A lot of persons, when their organizations procure a drone, they aren't fully prepared to use it because they don't want to be responsible. But with these little checks, it kind of gives you a chance to feel safe flying the drone. And this should always be documented for the next person coming. And data processing. So this is how you get your outputs. Joseph and Patrick would have been showing you some examples. There are softwares that, automatically does this for you, even down to georeferencing based on your location, based on the accuracy that you had wanted. And this is what you will get sometimes, your 3D models, etc. coming out. So that was just an example. Now, just to get into some of our solutions, GeoTech has partnered with many suppliers, because we understand a lot of organizations, especially in the Caribbean region, are sometimes just getting started with UAVs and may want to use use cases or pilot projects to get started. So we have a variety of options that obviously come at different costs. And what we always try to do is a user needs assessment to understand the needs of the organization, the needs of the project, and then make a recommendation. It's not like we're just trying to sell you a drone. We're trying to get you the deliverable that you want. So Leica is one of our suppliers, and we this is just an example of one of their solutions, the Leica AI bot. Its best uses is for in the construction, surveying, and cadastral surveying. The construction industry is using a lot of GIS applications as of recent, and it helps kind of give an idea as to how the project is going, monitoring your assets. Maybe you have a wide construction site and there equipment all over, and you need to monitor these things. Some of these things are rented, and you want to be, accountable for them. And you also sometimes want to see, some of the challenges you're undergoing with your project, and an aerial perspective would help with that. The cadastral surveying is something getting popular in the Caribbean region as well. People want to know property boundaries. Some of these maps are old in terms of paper-based, and a lot of organizations want to go digital now. So this solution is very good for that. Just to give an idea as to some of the specification, one of the most, popular questions is always flight time. A lot of, clients want to know how long would this drone last in the air, because sometimes you have wide areas and you may need to do multiple flights. So with this AI bot, you can get 24 minutes. Typically, flight time is affected by the geographical conditions, such as wind speeds, maybe even the terrain. There is a max area coverage of about 64 hectares. Mapping accuracy can go down to 4 centimeters. And as mentioned before, there are many payloads that can go onto drones that can even get data more accurate. There are supported processing softwares with this solution. Some solutions come with third-party software. Some actually you need to use what the supplier is providing. And the price range can vary from around 40,000 US go up. Then another one of our solutions include RUID. With RUID, we also have a fixed wing solution because some clients request fixed wing. Fixed wing usually gives you longer flight times. I'll go into the specifications and you can see. But it also has its pros and cons compared to rotary drones, which also give you like vertical takeoff, etc. Sometimes you can run the drone back if you want to change directions, etc., which is not easily done with fixed wings. Best uses for the RUID solutions include, topographic surveying, construction, again, monitoring, even in cases of environmental monitoring or even security. The specifications coming across some of the solutions, you can get larger, increased flight times of 60+ minutes with the Sky Cruiser, which is the fixed wing. With the X63, you can get about 50 to 60 minutes. Now, always bear in mind the payload on the drone affects its flight time. Some payloads are heavier than others. And it's always good to note that these are just estimates. Your flight time may be less. It's always good to know flight time because you don't want to send your drone beyond a reach where it probably won't make it back before the battery is dead. It can take additional payloads. As mentioned, some solutions come with fixed payloads, some can be more flexible. Max flight altitudes of about 4,000 meters. This is important because the higher you fly a drone, the larger the area or the quicker the flight execution may go, although you may not get as great as a resolution as flying low, but some persons would request a very high flight altitude. Bear in mind rules and regulations of your local authorities in terms of how high you can fly or permissions of flying high in certain areas. The outputs normally come with the processing software, but just to give you an idea, yes, you'll be getting elevation models, point cloud, automosaics. Price ranges of around 20,000 for the fixed wing go up and 8,500 USD for the rotary. And finally, one of our more popular solutions, it's not limited to just these two. These two are just one of the more highly requested because, as I mentioned earlier, a lot of clients want to do a use case for the organization and they don't want to go with the most expensive solution first. So this is one that sometimes we normally recommend, the Phantom 4 and the Mavic Pro 2. It has a wide range of uses just because it's a very flexible drone, topographic surveying, agriculture, monitoring, tracking. The reason why asterisk is there because some of these solutions actually come with, special features that allow you to, let's say if you're in a vehicle and you want to move while the drone is collecting data and staying in your line of sight. These are some of the special features that come. Construction and inspection again, and recreational use. Some of the specs on these drones, they are similar. 30 minutes flight time average, a max altitude of about 6,000 meters. They take additional payloads. They're very flexible with some payloads. And their price range is about 3,000 US go up. Other services GeoTechVision provides, we don't only try to sell persons drones, we work with our suppliers to offer services such as training. We try to always give complimentary training, sometimes with our UAV systems, or maybe your organization already have a drone, but they want to get training in specific use cases. We provide that. Support, sometimes it's used with warranties, repairs, etc. In terms of the surveying and data collection, maybe you want an expert there to kind of guide it because you tried before and it's not giving you the expected result. And we also provide support in terms of software. the additional softwares that are sometimes necessary to give you the output, as you would have seen in Joseph's presentation. Pix4D, for example, is one of those. And sometimes organizations need to procure that elsewhere. So that's essentially it. If you have any interest in procuring UAVs, we encourage you guys to contact us. That's our email there, our phone contact. We will also be sending out this presentation because we have recorded it for organizations that may want to share, well, for persons that may want to share their organizations or other surveyors they may be aware of, interested in getting started with UAVs. And as I said, it's not just about selling you guys drones. Maybe you just want to have a discussion with us as to how to get started. We are here for that in terms of doing a user needs assessment and guiding you accordingly as to how UAVs can benefit your organization and be a really good return on investment. So thank you. Back over to you.
Excellent presentation, Josiah. We just have one question from the attendees. Dr. Young is asking, let's scroll up here. Okay, so Dr. Young is asking if you could just elaborate a bit more about the application of drone technology for construction. He's wondering, is this just to monitor the progress of large civil sites? So I'll open that question to Joseph or Josiah to respond.
Well, I can quickly even give an overview, but actually not just monitor, because there are solutions now, even with Esri. I believe the solution is drone to map. You actually can be calculating stockpiles and monitoring these in construction sites. Or maybe you are digging trenches and you want to make sure the depth of this is uniform throughout, or just want to monitor it. These UAV solutions can assist. They collect the data, and based on the sensors, you can actually get elevations, even if it's a stockpile and you want to monitor how high it's getting, as Joseph mentioned in his presentation, or how deep a trench or hole is on your site. You know, some of these things need to be a specific depth or specific measurements. You can monitor it. So it's not only just monitoring like an image or a map of the construction sites. Also, you can actually do a time lapse for stakeholders. So you can fly a drone. Let's say you're doing a drone flight once a week. Every 3 months, you have to do a report. You can actually give a time lapse that shows them how the project has been progressing over time. The drone flight is a great way to kind of get a quick assessment of your construction site, and maybe you're remote and you don't want to be there to give a lot of instructions. So its application expands, outside of just mapping. And if Joseph has anything to add, he can also.
No, not much to add. The accuracy depends on whether you use an RTK drone or not. So if you work in any sort of civil engineering construction setting, you need a RTK drone, or you need ground control points to make sure that you have accurate measurements on depth, anything that Joshua mentioned.
Yeah.
Okay. All right, thank you. We have another question. Joseph, I see you typing the answer. Would you like to respond live? So the question is, what is the biggest pain in drone operation? What would you expect? What would you expect to improve on drone? I think you're saying improve on your drone solution, such as battery life, the capacity issue. Is it an issue with data processing, data post-processing, or something else? What is really the biggest pain when operating a drone? So, Joseph, I'll just allow you to answer since you started typing.
Okay. Well, the biggest pain is getting a flight authorization or clearance for a unique mission, because the classic, fly around a building or something like this are usually easy authorization to obtain. But if you want to do a BVLOS flight, which is beyond visual line of sight, in an area with a dense air traffic, this is going to be difficult. So you need to be properly trained, you need to have equipment that's maintained, you need to demonstrate that you have the capacity to do this. It's a lot of work to prove that you are a safe operator, that your equipment is safe, and that your plan is sound. That's the biggest thing. Battery life is increasing honestly every month. You can see that, you know, technology from other industry like cars can slowly trickling down to drones. Data processing can take time when you cover very large areas, but again, it's planning. You just need to plan for that. If you have more than 10,000 pictures or 15,000, you do hit a wall. I've done a project with 125,000 pictures, and we needed to use a specialized software. But I believe that the capacity increases, and once you get to those numbers, you have a sense of where that wall is.
Good. Josiah, anything else to add to that? I think you covered.
Well, my biggest challenge, one of my first projects, and Joseph was assisting me with, was actually with post-processing. I would always say, if you get a gauge as to how large your area is, it's really important to know, you know, how to execute your flight. That's why flight planning is important. You don't want to try and force the entire area into one flight. You may want to chop it up into different flights. Also factor in the processing. You can't always just use any general hardware in terms of a computer or laptop to process the data, because it may take days. I've had instances where it took me like 6 hours to get my outputs from processing software. And then you may have an instance where you probably lost power or an error, and then you have to start, you know. So post-processing has been an issue for me. My way around that is kind of from experience. You just learn the hard way, but it's also good. That's why I think when Patrick encouraged you guys to go to We Robotics, it's also good to kind of get the feedback as to what went wrong in similar projects. Because if you go to use cases, if you look at use cases of similar projects that you're trying to execute, whether it's environmental monitoring, construction, just general topographic maps, in similar areas as yours, you will kind of get an idea as to the challenges you may encounter. And that's always good to know. So don't always try to force a flight. Do your research. I always encourage persons, do your homework. Look, you know, always stay informed, because sometimes there are new solutions released every day that can make your flight operation, you know, much more efficient and much easier.
Okay, thank you, Josiah. I have another question here from Dr. Young. Is the use of drone technology for courier being employed in the Caribbean? Do you think this as a business would do well in our region? And I'll allow Valerie to answer that.
All right, so thanks for that question, Dr. Young. I do not know of any place that is currently employing it actively as a wholesale. I know of one organization who was in the process of testing such, but I may not know of all that is going on out there. But I do know that it has some applications. So some of the challenges that we run into are some of the same things that we run into with GIS in terms of our addressing systems and other means of, but it becomes a little less complicated with the drone solutions. There may be an opportunity for it to do well in our region. I guess the requisite research from a business perspective would just need to be done to see whether or not there would be that kind of uptake. And of course, the desire to work with the regulatory authorities. One of the challenges in our region is that the different regulatory authorities have different rules. And so you have to work with them to, in some instances, because I remember a couple of years ago, most of them wanted to ban drones. And so we were actively working with many of the different authorities across the region saying, regulate, but not ban. And so it's a matter of how to get over those kinds of obstacles to make it a viable business venture.
Just giving a few more seconds in case there's any last minute question. There's seen another question here from Timothy Thwaites. As surveyors, we should be primarily concerned with accuracy, not just getting a result. What are the pieces of quality control advice that you can give? I'm sure if Joseph, sorry.
He can start to share.
I mean, you're more versed, but I would say in my experience, understanding what accuracy you're looking for, because you can easily reference that based on the drone. I gave the specification gives you general accuracy. So once you identify, okay, I need to go less than 2 centimeters, I need to go as accurate as I can get. You have to have a defined, you have to have something defined, a target, and then there are solutions that can match that, as there are RTK solutions. Sometimes the UAVs have payloads that can help you go a little more accurate. And then there are certain workflows that help in terms of like ground control points. There's a specific way or a better way to do that that helps with quality control. And then we always encourage that in our workflows, having that quality assurance and quality control. So from my perspective, that's one of the approaches that you can take. And Joseph.
Okay. Yeah, so one option, it's not always feasible, is to collect more ground control points than needed and use some for validation. That's as long as the ground control points have been collected properly, which is another issue. But when you use them for validation, you know that your model is sound. That's key. So it's kind of a quality control technique that I would use sometimes. And then there's a question, how many ground control points per area and so on. There's a debate about this, but let's say minimum of 5 per square kilometers. Don't quote me on that, but I usually tend to do 15 to 20, which takes time. So if you want to do additional ones, it takes even more time. So it's sometimes not necessarily feasible. The other thing is to understand your equipment and tools. So don't just believe the processing report, understand how it works. So, the training from GeoTechVision can help you with that. Make sure that you understand what the output means.
Okay, thank you, Josiah and Joseph. I believe all questions are answered. So I'll now turn. Sorry, you were saying something, Josiah?
No, well, if you were going to hand over to closing remarks, I'm just reminding persons of the survey in the chat for surveyors that have joined in and are trying to get CE points for the webinar. If you didn't get the input that to join the webinar, I'm putting a survey in the chat. That's what I want to leave your information so you can ensure this can happen. Over to you.
Okay, thanks. All right, so before I hand over to Ms. Grant to give her closing remarks, I'm just going to read her bio before. So Ms. Grant is a successful award-winning entrepreneur and one of the Caribbean's leading exponents of geospatial technologies and location sciences. Ms. Grant is the managing director and founder of GeoTechVision, and she founded and built it into a reliable and quality provider of a range of customized services and data-driven solutions to regional governments, NGOs, and corporate entities. So over to you, Ms. Grant.
All right, thank you, Cherie, and thanks to Patrick and Joseph and Josiah for this webinar, and Terry for putting all of this together, and for the team that worked in the background. I want to thank all the participants for participating in this webinar and for asking those questions. UAV market, it's more than a $20 billion market these days. So it's quite an important section of our industry. And not only are drones eco-friendly gadgets, but they're being widely used in so many different ways, in commercial ways, in professional, in recreational, in industrial, and for private purposes. And so we've come to see that a range of applications surrounds it. I like Dr. Young's question about how is it used in construction. And so I was thinking about it, and I could count. You could use it to track, you could use it to map, you could use it for survey, for inspecting, for managing more efficiently and more safely on some of those construction sites. So we come to realize that there's a range of applications that UAVs allow us. And we always think of UAVs just from an overhead perspective. And certainly that is the perspective that we're looking at today. But we're going to invite you back at some point that we're going to look at the underwater perspective, because there are marine drones that are there and so applicable to the Caribbean region. So GeoTechVision and Jamaica Flying Labs have been working across the Caribbean, across the US, and we have been implementing several solutions to do with drones and the various geospatial technologies. And so wanted to say that we're here to assist you with all of those needs and to guide you as to how best to maximize the use of those technologies. As Josiah mentioned, we always begin all of our engagements with a user needs assessment. So we want to kind of understand what it is that you want to get done, and then we can advise you properly as to how to get it done. So we look forward to working with all of you in the days ahead as we can help you on your different UAV projects out there. So looking forward to that. And thank you so much for being a part of our second stop on our virtual roadshow.
Okay, thank you, panelists, thank you, attendees, and wish you a good day. The information is in the chat, the survey link for you to fill out. LSAJ members, please ensure that you fill out that survey link. Josiah, I think you're muted for speaking.
Oh, no. I realized I posted the link again. It was the panelists only, so I'm just sharing for attendees. So once you guys fill it out, thanks for attending. Say thank you to Joseph and Patrick, Shuri, and everyone who helped put this together. We hope it was informative, and do look out for more. We will be sharing these clips. Follow us, and you should receive recordings of it if you need to share to your organization and is interested in learning more.
And we're also, as Patrick would have mentioned, we're interested in building out the local drone ecosystem. So if you're interested in working with Jamaica Flying Labs, please feel free to reach out. We can provide you with some more information as to how you can make a difference in the local community. So thank you again, and
see you guys at the next one.